Hello everyone. So in this video we're gonna be discussing about our chapter number 6, gravitation. So of physics. So in first of all we're gonna see that Newton's law of gravitation, universe gravitation, the same. So what the statement says, the statement says that the gravitational force of attraction, we know that when two masses exist they have the force of attraction. Why? Now the question arises that you and your friend is sitting, but why don't you feel force of attraction? Just because you have less masses. The force of attraction is only being applicable when we have the heaviest bodies. For example, Jupiter and Sun, Earth and Sun, these are the heavier bodies. So that is why the force of attraction or the gravitational attraction feel there, not in the human or the normal life. So the gravitational force of attraction between two masses is directly proportional to the magnitude or the product and inversely proportional to the square of the distance between them. So if I place that there is a body m1 and m2, these two bodies are applying the force of attraction between each other. So here this is m1 and this is m2 and this is r over square. So their distance is inversely proportional to the square of their to these masses, right? Let's see mathematically how. We know that force of gravitation is directly proportional to the m1 and m2, and it is said that the force is inversely proportional to the square of the distance between them. So if we remove this directly sign, we have F is equal to G m1 m2 over r square. G here is the gravitational constant. So now if I could say that if you increase the distance, if you will increase the distance, okay, the distance will be increased, so the force will be decreased, because we know that distance is inversely proportional to force. Here is ball, here is another ball, okay, you are here is magnet and here is another magnet, for example, सही है. तो आपने उसका डिस्टेंस बढ़ा दिया, तो इनके बीच में जो फोर्स ऑफ अट्रैक्शन होगी वो ज़्यादा होगी या कम होगी? ऑफ कोर्स दे विल नॉट अट्रैक्ट, तो कम हो जाएगी. दैट इज़ वाई इससे हम लॉ ऑफ ग्रेविटेशन कहते हैं. दैट इज़ वाई इन्वर्सली प्रोपोर्शनल है डिस्टेंस के. डिस्टेंस इन्वर्सली प्रोपोर्शनल होगा. नाउ हियर द गुड क्वेश्चन अराइजेस, यहाँ पे स्क्वायर क्यों है? हमने तो एक ही मतलब स्क्वायर क्यों है? हमारे पास सिर्फ आर डिस्टेंस क्यों नहीं है? जस्ट बिकॉज हमारे पास जो कोई भी बेसिस नेचर ऑफ फोर्सेस होती है ना, तो वो इन्वर्स लॉ को फॉलो करती हैं. इन्वर्स लॉ या फिर इन्वर्स स्क्वायर लॉ को फॉलो करती हैं. तभी हमें पता है कि हमारे पास चार बेसिक नेचर ऑफ फोर्स थी, उनमें से ग्रेविटेशनल भी फोर्स थी. तो वो जब इन्वर्स लॉ को फॉलो करती हैं तो उनके पास स्क्वायर आता है. अब नाउ इफ आई कुड गिव यू द एग्जांपल, वी हैव कूलम्स लॉ. तो कूलम्स लॉ इज़ लाइक एप्लीकेबल ऑन electromagnetic stuffs, right? So we have F is equal to K Q1 Q2 over R square, right? So इसीलिए यहाँ पे हमें स्क्वायर आएगा. Now let's just drive it. Now we're gonna see that how we have derived the gravitational unit. Here r square. When r square will be going there, it will be multiplying. So f r square is equal to g m1 m2. Okay, now we have to find g. When we have to find the value of g will be coming out, and r square f, and these both are multiplying here. When they'll go down, they'll be in the form of division. So radius meter square, force we have the unit of Newton, mass we have kilogram, so we have the unit of gravitational universal constant, that is Newton meter square upon kilogram square, right? And this was given by Henry Cavendish, right? And if I talk about the dimension of gravitational constant is m minus 1, L3 and T minus 2, right? So now we're gonna see the key points.